try to make this a very quick overview of polynomials. Mostly I want to make sure we have the vocabulary. That's really what it's about, and I think degree is about the only thing we haven't talked about. There's one particular kind of polynomial we've dealt with quite a bit, and we really have to know what standard form is. That's going to be really important in some of the operations we perform on polynomials. I've got a couple big polynomial expressions here. We can look at polynomial expressions or equations or look at them as functions. Right now I just have expressions. There's no equal signs. There's no function notation. So these are just expressions. And most basic terminology, poly means many and mono means one. So a polynomial has many terms or more than one term, and a monomial is just one term. So this polynomial is built up of many terms. That's a term, that's a term, that's a term, that's a term, that's a term. Their terms are separated by addition. So you can think of it 5x to the fourth as a term. It's a monomial. It's separated by addition from negative 2x to the third, which is separated by addition from positive x squared, etc. And so this one happens to be in standard form. Standard form is in descending order of the exponents. The exponents here go from the biggest number, smaller, 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 and then the last one is just a constant. Each of the rest of them have a coefficient, or in this case the coefficient is 1. They have a coefficient and a variable, and the last one doesn't have a variable, so it's just a constant. So descending order of the exponents is what gets us standard form. And that also helps us see the degree of the polynomial. In this case, the degree is 4, because it's the number of the highest exponent. And when we talk about the degree of a polynomial, that's going to tell us very important things about its graph, etc. And the other important thing when we talk about the leading coefficient of a polynomial, it has to be in standard form. So in this case, the leading coefficient is 5. If we look at the next one, it's not in standard form. So in order to put it in standard form, we're going to have to do some work. So I'm going to look for the biggest exponent. There's the biggest exponent. And so that's going to come first. And so I'm going to just cross these out as I go. Now this one is missing terms. It doesn't have to have every one. Be real careful with the signs because that negative travels with the 2x. So it's missing the x squared term. It doesn't have a constant. That's okay. So now this is in standard form. The degree is 5 and the leading coefficient is negative 3. So I think we talked about all the vocab that's on the list, but I do want to make a quick little chart with you about polynomials with various degrees and what we know about them. So first degree polynomials are what we dealt with throughout Algebra 1 a lot and throughout Chapter 1 and 2, or 2 and 3 here. So just a linear equation might be, something that we put in slope-intercept form. It's just got an x, so the highest exponent is 1, right? We don't usually write it. This next one we just spent a lot of time with. You deal with a little bit in Algebra 1, but a lot in Algebra 2. Quadratic, that's when you have x squared. What we're going to be getting into this chapter is more with quadratics, but also cubics, right? Third power is cubed, so cubic is x to the third. And quartics, we'll deal with other higher ones too. Not quadratics. I always want that to be quadratic, but it's not. It's like a quart of milk, quartic. So that's x to the fourth. So it's not as important that you know that quartic is to the fourth. We're going to deal with cubics a lot. So a quick little review of the vocab. Make sure you know what all those are. And your EQs.